Welcome to Bitbuilders, where we sit down with the greatest minds building and exploring robotics in construction and space. Before we get started though, if you're a startup founder or operator responsible for innovation in your company, or you want a deeper, more insightful look into technology in AEC, you won't want to miss our newsletter. From deep dives into particular technologies such as AI, robotics, design, software, and so on. Hot takes from investors betting big in AEC technology and advice on building tech companies, including the stories and takeaways of the most successful AEC technology founders. Head over to www.bricks-bytes.com and sign up today to get this exclusive material straight to your inbox. And now for the episode.
Hi, Yegor. Welcome on Bitbuilders.
Hey, Gabriel.
It's great to have you here. We've chatted a bit in the last few months, and I mean, I've asked you to come to the pod because I think you have a super interesting story to share. But why don't you start by introducing yourself, and then we'll take it from there.
Sure. So I'm Yegor Anchyshkin. I come from Ukraine originally. I'm CEO and co-founder of a company called InStock. There are many InStock's, but there is only one InStock.com. And this is my third startup. For the past 15 years, I work in the area of e-commerce fulfillment. So basically everything around how do you fulfill the orders, pick, pack, and deliver. I started working in this area from the company that I founded in Ukraine that was called Zakaz.ua, which was grocery delivery from supermarkets. And you can imagine that groceries are one of the hardest categories to go into, especially when you're doing the full process, pick, pack, go through POS, stage, and deliver, and sometimes even manage cash and delivery. But that's what brought me into this fascinating area, and I'm still doing this, but now is robots.
That's also, that's everything that you've said in general. It's something that fits our definition, right? So Bitbuilders, people that are building hard stuff, again, gets even harder when you're building with robots. Or am I wrong? Is it easier to build it with people?
It is getting much harder when you're building it with new type of robots that are not commercially at the shelf. Right, because every hardware category, it takes many, many years for it to mature. And people talk about valley of death, right, between for seed round and Series A. But for us, with the new hardware categories, for many companies, it's a valley of shame because you are creating new device, you're on your own very often, and you have to make it reliable, right? If the device is not reliable, then users are just not interested. They don't have time to kind of play endlessly with new hardware. So it's super hard when it comes to robots, and we are standing on the shoulders of giants, but not in such a way how you do it when you're doing it in a pure software way. In a pure software way, you are in the digital system and you immediately enjoy a lot of what I would say is a luxury, right, of the digital system. When you're doing robots, you start from scratch again.
And there's a lot to unpack there. And I'd love to dive into, what led you here. And then I really want to try to unpack what you said, for example, about what the customer wants. So I think there lies the key of, what this entire market for robotics and automation within warehouses and systems where you basically have to collect, put in place stuff. But I want to start from, where you've been. What's your background in? You studied STEM in Ukraine, if I'm not wrong. Where do you come from in that sense?
I have my bachelor's and master's degree in computer science and mathematics from what's called Institute of Physics and Technology, which is like one of the sort of Soviet attempts to replicate MIT or like good technical schools, so to say, right? And it was a hard school. It gave us a lot. And right after having my master's, I jumped into one of the first venture funds in Ukraine, and basically I spent 3 years looking under every rock, trying to invest various teams and companies, and I've done in 3 years only one deal, but it was a good one. And then I just decided to do my own startup. That's how I came to be CTO, and I found my co-founders. The startup was Bitbuilders. It was a facial recognition technology for movies, for moving images, videos, still images, and then gestures. That one eventually got acquired by Google in 2012. And then,
what was that experience like?
well, that was, of course, a roller coaster because you're jumping into the startup world based on some kind of limited exposure to the experience of other venture capitalists, right? And you haven't been in the depth. So I started that company when I was 26. But we immediately got some interest from customers, first in New York. It was mostly media companies. They were interested to index their video archives. For example, Reuters was a pilot customer. And then we moved to LA, where entertainment companies were indexing their videos, and then eventually to Silicon Valley, where we were putting our face recognition technology onto chipsets, so working with Motorola and others, and that eventually what was of interest for Motorola, which became at that moment part of Google. And Motorola, Google acquired the company then.
Hey listeners, I want to take a quick break to remind you about the Bricks and Bytes newsletter. If you're interested in learning about the technology shaping the future of construction, you won't want to miss the valuable insights we share each week. To get this exclusive content delivered straight to your inbox, head over to www.bricks-bytes.com and sign up today. Link is in the show notes. Back to the show.
Gotcha. And so that it was a similar, there's a lot of computer vision involved in what you're doing today, but that might have been the seed that made that interest grow, wasn't it?
Absolutely. Computer vision is a super fascinating area for me. It just, first of all, it's one of those areas where you can stand on the shoulders of giants, right? You have the cameras are cheap, you stick it somewhere into some device or just anywhere, and you have a digital signal from this analog world around you, and you can do a lot of stuff with that digital signal. It's not often that you take some sensor and you immediately understand the output of a sensor, you can play with it, and you can trust the output. Because with many other sensors, first of all, the output is much less information rich, and it's more noisy. So you have to dance much more around getting some useful bits out of the sensor signal. With camera, it's very information rich, so huge data flow, and you can trust it, and you can understand immediately the human, and it is great. So computer vision was always my kind of area of interest.
I love it, and I think in the end, I imagine it might have been a good outcome with that. But then, what did you do next? Like, why did you say, okay, let's kind of like start over with this, with this roller coaster? Was that all you could do?
Yeah, well, probably yes. Psychologically, I don't see myself working as a kind of cog in a huge system. I want to bring something new to the world and solve some problem that is tangible for people around me. I'm not saying like for everyone, but for some large group of people that I can observe, right? And that's what is very joyful for me. And so like I thought, okay, we have a lot of mundane, repetitive jobs that people don't like, right? I haven't seen super happy people on, let's say, POS register. And that was one of the uh, things that was kind of obvious for me. You're in the supermarket, you're pushing a cart. So I thought like, okay, how robots can solve this, at least partially, the problem for people. And I thought that, okay, let us start from human picking. So basically, Instacart was started 2 years after us. And let's then substitute human picking with a robotics part. Of course, that didn't happen within the scope of one company. While we were raising our Series A in Boston, Massachusetts, we expanded from Ukraine to Massachusetts in 2015. While we were raising that Series A, we got into conversation with Takeoff Technology, and it all ended up in they acquiring us, and that's how we got to robotics. But it's more or less the same story. It's how do you do e-commerce fulfillment in the more and more robotic, automated way, so that people don't have to spend time on the not interesting mundane parts like going between the aisles, selecting things, and just cut this part out, right? Like trust it to robots, and but you have to do it in a very, let's say, smart way if you want to have success in that area. So it's not that easy as it seems.
And so you've actually explained me what the thesis for what you're building right now with InStock is. Why don't you explain it to the audience? I think what can make a ton of sense is if you contextualize, where are we when we're putting systems, that InStock is developing at use, and who are we serving? And kind of like, why is there a missing piece that InStock can be the leader of filling?
Sure. So whenever you go and you see on YouTube some automation in the warehouse, right? You typically see a huge warehouse, 1,000,000 square foot, 500,000 square foot. And it's not because this is the only warehouses where automation can be beneficial. It's because automation can be made affordable only in the setting of a huge warehouse where you have literally hundreds of thousands of square feet under automation footprint. And that's not a coincidence, right? Right now, robots require so much babysitting that it makes sense to apply them only in massive quantity and where you can afford to have a robot babysitting team of technicians right near them. And it's kind of natural, right? When automobiles appeared, probably every, when they just appeared, let's say in the first 10 years, every customer would have their own mechanic and their own garage, right? And there were like early computers required you to understand something about computers and so on. So it's just early days of hardware category, of hardware platform. And it's get maturing in various subdomains, but that's where we are in general. It's an early hardware device category. And right now it requires a lot of babysitting. And that's why you don't see automation applied in small use case, right? You don't see like 1,000 square foot under automation. You don't see it in homes and so on. It's just incredibly hard to make automation super reliable so that people can, or small businesses can acquire it and use it and maybe call technician once a year. But that is what's required for any device category to penetrate to mass market. Right? Imagine you would have to service your car every week. Is it fun? No, right? Or your fridge. You never bring your fridge to a service center, and you hardly ever are calling technician to service your fridge, right? So that's where the industry is going right now. In my view, we just have to pedal as fast as we can towards higher reliability and lower cost to make robots applicable to small use case, to smaller warehouses, to smaller installation, to smaller businesses, basically to open mass market for this device category. Right now, it's kind of locked in this huge luxury, I would say, a use case of a large warehouse and large automation need.
And delving down into the reasons. This is a podcast of nerds, so we say nerdy things all the time. So don't worry about going deep on this. What is it that you think it's blocking the adoption? I understand that miniaturization, for example, of technology could be one of the examples. So if you have a gigantic, robotic installation that picks and delivers packages, you're basically spreading out fixed cost, and so there's definitely a piece of that. But what is that technologically has been denying that?
So if we are trying to unpack the architecture and technology problem that kind of are hard to solve, that are blocking this high reliability, lower cost, and penetration, there are a couple of levels, right? First, it's of course the maturity of components. So, for example, in InStock, we're using hub wheel BLDC motors, and we're buying them from a good factory in Asia. And the only reason why those wheels are at a pretty attractive price point is because that same factory is manufacturing hoverboards and scooters, wheels for hoverboards and scooters. So we are piggybacking on consumer market. If that factory would not be manufacturing something for consumer market, the price would be very different. So that's one of the components that has matured, and we are using it immediately. But some other components have not matured. Now, of course, if you are designing and manufacturing device like the InStock robot that drives on ceiling and walls, there will be some significant, substantial part of components that are just yours. They're custom made, and you have to have certain volume and quantity to have a better cost of those components. So one is just maturity of components. Another one is how do you architect the use case? Because if you there are two very distinct use cases for me. One is the robot is between people, right? You have, I don't know, a vacuum cleaner robot in your house. You have humanoid robot in a factory. As soon as you said, "Oh, my device, my robot will be among people and it will be mobile," you basically jumped to the incredible level of complexity that is required to make that robot safe. It should be either very light or very smart, or move with a very low speed. But if you want something that is really useful, sometimes you cannot get this done without robot maybe being 90 pounds. And maybe you want it to move with human speeds at least. So we're talking, 1 meter a second. And to make something that is 90 pounds and moves with 1 meter a second among people safely, it has to be incredibly intelligent, absolutely super duper smart relative to where we are now, right? So it's not easy to get that level of intelligence for that use case. And then there is another group of use cases. It's when you cage something. And I think people are so much focused right now on getting, sort of, as they say, robots out of the cage, that they forget that you can also rethink the cage, right? So right now in our mind, the cage is okay, the best example would be robots in the automotive plant factory, right? You have huge cage, you have huge arm. It's probably 4,000 pounds, and it's moving with incredible speeds and doing welding. And the people are nowhere in this cage, and it's reliable and so on. And of course, these robots are already successful. But you can imagine that there are other ways to build those cages. It can be still a cage, right? So people don't go in on a normal day. But inside, you have a more lightweight robots, and you have almost like a society of robots doing some work together. This is a super interesting, exciting architecture that we are building. Of course, it's super interesting and exciting for us. And we try to basically kind of turn people's attention a little bit from this use case of, oh, robots should be among us, towards like, hey, there is another way to think about the cage. It can be low maintenance cost. It can be maintained by the user, consumer, small business themselves. You just have to rethink and re-architect how you build that cage, right? And what kind of moving mechanism is inside, right? If it's a lightweight robot that you can simply insert in and take out, so you can maintain it, then it becomes very attractive.
Gotcha. So so that's why the industry in industrial robots has been kind of like differentiating between industrial robots and cobots. Cobots can be among people, industrial robots can't. And then what you're thinking is, if you're an industrial robot or something that doesn't have contact, if you raise the level of efficiency of the system by making the entire environment that's secluded from the operator, more intelligent, more interactive, easy to interact with actually, then you're basically lowering the bar for adoption.
You're absolutely right. Yes. And we just think that it's people underestimate how hard it is to make a robot that is among people useful and safe simultaneously. Because if I have a super safe robot that basically is moving slowly, then I'm not impressed. It cannot do anything good for me. I'm impressed, for something to gain traction and to penetrate the market quickly, there should be some sort of delta and perception of value, right? So delta in usefulness, right? So you cannot run as a human with 60 miles per hour, right? And carry a lot of things with you. Automobile can. You cannot compute so much things in your memory as you do inside your computer and CPU. That's kind of obvious, but that's a delta that is required to penetrate quickly. So if I have a robot that is I was picking with the rate, 100 lines per hour, and it helps me to pick with 120 lines per hour, it's a very, very limited value. But if I have something that is, okay, it's enclosed, it's caged, but it is moving inside of that cage with incredible speed, right? And exerting so much performance that the whole cage becomes really, really useful for me. Now we're talking. Now I'm interested to know the price. I wanted to have it, and I wanted to be affordable for me. So those cages, there can be extremely high performance inside, thanks to the fact that there are no humans near you, right? In the same way as there are no human hands inside the engine of your automobile, and there are no human hands without your CPU, right? In order for something to work efficiently, you have to isolate it, you have to cage it, you have to make a container. And so there is a container in this cage, and something can work extremely fast and exert great performance. And the question is now comes to cost. What's the price? And of course, it's a total cost of ownership, because if the cost is $10, but it breaks every day, and I have to call a technician for $300 per hour, then it doesn't work for me from a TCO perspective.
That's fully clear. And InStock is actually building high performance robots in highly intelligent cages too. Also, the cage actually makes a ton of sense. So we're on a podcast, most people will actually listen to this. So you probably have made this effort before, but it's really hard because, it's something, it's your baby, not mine. I will not be able to describe it this well. Can you describe it to the audience so that they can picture it? What is it that exactly the system that you're selling at InStock looks like?
Sure. So this is a system that looks like from exterior as an industrial racking, you may say, right? So the three-dimensional tall system can be 30, 35 feet tall and occupy all available vertical height in the warehouse. And it can can be of various shapes and forms, can be as shaped as a cube or as a long brick, cuboid. Inside of that cube, you have only robots. We have only one type of a robot. So there are multiple levels. So it looks like a multi-story building to a certain degree. The robots can drive on the floors of that multi-story building, on the walls in some places, and also on a ceiling. So all ceiling is drivable and all floor is drivable. And they drive on ceiling and floors more as automobiles drive on the road. So it's just a flat open space and the robot itself decides how to drive. So it's more like an automobile rather than a train on a track where there is something predefined and therefore like the robot can move only along the line or some kind of hardware track. So the robots are just driving, and it's a society of robots. There are many of them, and we control them so they can do tasks together. They collaborate. The only collaborative operation that they do right now is passing a bin. So the robot can take a bin with inventory and pass to another robot. Because, the robot from a ceiling can pass to the robot on the floor or vice versa, take the bin from the robot on the floor. So, but it's the same robot again. So we are manufacturing and designing only one robot. All of that is designed in such a way so we could create density. So we utilize stacks of bins, and we can also control how those stacks are located in the grid. So the same space is used for storage and for robot driving. So in some sense, it's like a huge parking lot, and we can say, okay, the cars will be parked here and the driveways will be here. Or we can change our mind tomorrow because it's a peak season. We have to change some assortment, and we will decide, no, there will be fewer storage locations. There will be more driving space because that's what's necessary for highest throughput, for example. So it's a very flexible system inside that is basically, that has only one moving element, type of element. This is one robot. And the robot is 90 pounds. So two people can easily carry it, and one person can deploy it, and one person can take the robot out from the system when necessary.
And so I think you did an amazing job at letting us picture this. What is the interface between the human and that system?
So in here, we are trying to innovate in only very few places. So first of all, it's a goods to person system. So all goods to person system, they assume that you have certain places like workstations. Some other companies call them ports, or use other words. And humans are more or less stationary at those workstations. One workstation, one human. The robots are coming with inventory, and human is doing one of the operations, right? Take the couple of pieces out, or put a couple of pieces in if it's an inbound operation. And so this functionality is the same for all goods to persons, right? You're bringing inventory, you bring goods to person. So if those goods are stored in plastic bins, and plastic bins are now becoming absolutely dominant form factor for storage, then everything is measured in sort of like machine rate of how many bins you can present per hour, so-called bin presentations per hour. So here, the systems are very comparable and they create the same functionality. But how the workstation is organized can differ a lot between vendors and even between customers of the same vendor. In the case of InStock, we're extremely flexible in terms of how workstation can be organized. It can be organized more as a kind of in-out several channels where robots go in and out in the same in one channel, or it can be organized as a conveyor where robots are just passing by, or it can be organized as several, like two conveyors that are have this whirlpools right near you, and you working sort of in a corner, having one conveyor on the left, one conveyor on the right. So why it is necessary? The flexibility of the workstation organization is extremely important to organize, to fit into the process and to optimize the process for the customer. Because customers have a lot of variability of what they need and what they want from their pick and pack process. Some customers would combine picking with packing. Some customers will pick into some intermediary storage medium, some kind of trolley or cart, and then push that trolley to the packing station. Some customers are picking onto plastic bins that are also intermediary storage, but on a conveyor. So there are a myriad of variation what can be the most optimal, the most wanted organization, and you need automated storage and retrieval system to fit rather than demand certain constraints, right? So with InStock, you can build pretty much everything. You can combine with automated picking arm and so on.
And I guess that modularity and reconfigurability, which, by the way, I've also noticed it's in the structure and in the robot. So the robot, you can basically manufacture and many of the same robot. The building blocks of the structure, actually, I can imagine panels and trusses that you can build and kind of like expand and contract whatever you want. But I guess that modularity, what it does is it helps you with the pitch to the customer. Hey, you don't have to change your current operations. We don't have to, you wouldn't have to completely redesign everything that you do. We can somehow adapt. What is it that the customer wants? What are the priorities of, so we said segmenting it, smaller customers than the usual warehouse that you would see that have need of automated operations?
Well, just to clarify, there is a customer size and there is installation size. Large customer does not mean that you want only huge installations, right? I mean, McDonald's can be a big customer, but each location is tiny, so the requirements can be sort of for nano located. And so the smaller the location, the more flexibility and reliability is required. Because why more flexibility? Because every time you find yourself into some already existing room, the time of like extreme build of new large warehouses, I think it's not over, but it's kind of fading. More and more, you have to be able to fit into some brownfield environment, right? First of all, for a reason, because like e-commerce businesses want to move closer to urban areas and into the urban areas just to reduce delivery time and just physics. There is no other way to beat it. And second, just because it's harder to build even in suburbia, right? So you are operating very often from the brownfield environment. And that means that when you come, you find yourself with kind of in the room with certain limitations: bathroom here, column there, fire exit near that obstacle, and so on. And you have to work around those kind of limitations. The second one is the small and mid-sized customers. It's harder for them to predict what will be the throughput and storage density required. You basically can very easily make 100% mistake, right? You thought you need 400 dph and you really need 800 dph because it's natural, right? The smaller the operation, the higher the fluctuations percentage-wise relative to the operation. And the third one is about planning. That's probably about the size of the customer. If you are moving between huge warehouses, then probably you have existing e-commerce flow and you may be growing, 10% a year. So it's more predictable, and you may talk to your landlord for a year or 2 years before moving into a new warehouse. So there are more greenfield use cases, or let's say when everything is moving. When you are in the setting of a small installation. Let's say there are a group of customers who cannot afford that, right? They have to try new tech in whatever room they already have. And no space is sitting idle. There is no kind of free room that is just sitting and waiting for you. So you have to be able to come and get your foot in the door by installing something small first. You say, look, why don't you? I can demonstrate the benefits and the ROI on 2,000 square feet. And then you can grow. Like you will like it, and then you will add another 3,000, and then it becomes doable, it's manageable, right? Because if you come to operations manager of any warehouse and you would ask them for, hey, do you have 10,000 square foot space for me right away? They'd say, no, absolutely not. Like no space is sitting idle. Inventory has this property of water. It's kind of expanding and it's taking everything that's available in the warehouse. So it's very beneficial for a system to be able to start small and then grow.
By the way, I love the water and inventory analogy because I can see it. I mean, I've been at a bunch of warehouses and stuff is lying everywhere. Like there's stuff in every single point.
Yeah, I mean, whenever you again see the videos on YouTube, everything is pristine, everything is so well organized and sort of square and plumb. In reality, is more complicated and sophisticated. There are peak seasons and there are new merchants, new vendors, new inventory coming all the time. So very often it's not that kind of square and plumb as you can imagine, right? And but that's realities of the business, and you have to still make it work.
And in the case of a smaller operation, in a smaller facility, so not a small customer, what is it that, how do you reduce the friction when you get into that facility first, right? So you have to command some downtime, you have to command some measurements, etc. What is it that you think it's key when trying to service these types of operations? When you want to be a supplier of some of these systems that are completely new, what is it that are some practices? You mentioned the ability of demoing the smaller prototype system, but what other
So to be clear, the
2,000,
3,000 square foot installation, it's not prototype, right? It's not POC. It's something that is going into production as soon as it's ready and is delivering value day one, right? So it's just probably the minimum size that for, say, majority of 3PL to start from. It just doesn't make sense to make it even smaller for third-party logistics companies. But there are other practices how to smooth this transition period, right? The deployment of the first automation, or if it's not the first, just kind of getting it up and running as smoothly as you can. For us, the biggest one is, of course, the simulation. So high fidelity simulator and a sandbox, that what allows you to first give the API immediately to a customer, right? So for example, IT team can take a look at API even before NDA is signed, right? There is no needs in NDAs or any contracts is not even on a horizon, but already you can take a look at the API. You can imagine how the integration will look like on the IT level and data level. And then you are taking parameters from a customer. Okay, what's your room size, where we can be in the room, what are the obstacles in that room, and you model the system. You can do full simulation. You kind of running the robots and there's digital twin. You can show this to customer, and very often you change things, right? So you play with parameters, more storage, less storage, more throughput, less throughput, but you have to come to a station that works from a technology perspective and is what customer will benefit from. Once you arrive to this, then you can test integration in that same sandbox with the customer's IT team. Then you can build, right? You have high level of confidence by then that you can build the installation itself. And after that, you have to kind of flip the switch and typically direct the flow of fulfillment orders to the system. And what we recommend in this case is also that the IT team of a customer can this switch, right? It's sort of flippable, right? So that you can direct the flow of orders into the old system and process or to the new system and process. That de-risks the launch very much, right? The type of launch where sort of everything, you think everything ready, everything works, and then you kind of cut off the old process and you turn on the new process. Very often that goes wrong, right? Because you can't predict everything. You better have the ability to soft launch. Even with the very mature ACRS systems, right? In the previous life, when I was working for Takeoff, we were working with a pretty mature ACRS from KNAPP, but there are so many nuances around integration, small ones, but every small nuance can halt the operation. That the soft launch feature helps a lot.
Understood. And I think you're the CEO of InStock, but the way that you're talking about your systems, it's really like I can see that you've been a CTO in your life, that you've thought about these problems very deeply from a technical standpoint. And I want to ask you, how are you guys organized within InStock in terms of prototyping, trying to understand, like finding new features? What are the philosophy principles that guide your product development? Because I think that's super interesting given the type of systems that you're building.
So you'll be surprised, but it's very simple. We embarked on certain architectural principles, right? So fully static infrastructure, only one robot. A customer should be able to deploy the robot and take the robot out, and certain performance needs. And that's easier said than done. So, but if you write down these architecture principles, and they're also the principles of what you want to deliver to your customers, what are the key characteristics of your product, then we're still on the journey to fulfill all of those, right? We haven't yet achieved kind of total success on all of those pillars. And so the principles were set. We all, as co-founders, agreed on them. We are actually a pretty large co-founder team where there are 5 of us. And so our CTO is responsible for, as I say, everything below Linux. We say that's the area he's driving. Victor, he's he's overseeing all of the mechanics, electronics, mechatronics, firmware, and interfaces, of course, between firmware and our kind of higher level software. And then another co-founder, Andrew, he is responsible for the robot software and the cloud software. So basically everything that is running on above operating systems. And that is also not easy because we have multiple robots coordinating between each other and cooperating to perform tasks. The areas of multi-agent pathfinding, multi-agent planning, we are taking some latest and greatest research results right from research papers and bringing them into our code. And that is, I have to say, very hard process because, nobody is researching and writing PhD thesis right for your case, right? They, like people play with some toy problems and toy situations, but every time you take some achievement from research paper and toy situation into the real practical world, you have to make a lot of adjustments for it just to barely work. And then not even saying like the long journey to the actual result that you are expecting from that research paper application. Yeah, so that's how we organize. I'm more or less responsible for business and product. And we have Rebecca, who is our chief of operations. He's responsible for everything customers. Right now, we have already one production level customer, and we're completely absorbed in basically delivering what we promise and keep our customer happy. Once let's say we have enough of the customer interest to sell many more, we have to feel confident that the timelines are predictable. And we're getting to this confidence level when we can actually say like, okay, this will be done in 6 months, and therefore let's sign a contract and let's build the system for you. Let's start installing it.
I'm curious on the commercial side, do system integrators play a part into trying to sell into these operations, or are they not really a player because they're a bit outside of the industrial space here?
Absolutely, system integrators are key for many vendors who are penetrating storage and retrieval market, right? To absolute majority of the vendors. We are not yet playing with system integrators. We go direct because if you are doing we're in the beginning of the journey, right? The first 10 installation you can do yourself, right? You have to be with the customer. You have to be on the customer side. You have to experience and feel all of the problems. Your throat should be the one to choke by customer, right? You don't want anyone in between yourself and a customer in the first, an installation, and can be 10, 20, and so on. Once you feel that, okay, it's absolutely repeatable, the error rates are tiny, it's super reliable, then an integrator becomes for you as one of the distribution channels that you have to consider. And it's a choice. I don't know what will be our choice, by the way, because we are tuned for very fast, direct distribution and penetration. For example, we are not hiding the design of the grid. Grid for us is a commodity. The infrastructure part, right? It's super simple, and we can trust customers to find contractors to install our grid, right? Because customers, they already have contractor. Guess like our customers, they are the ones who are installing, for example, commercial racking. So they are in contact with contractors in their territory. Like, for example, the first installation for us was in Toronto. I don't know anyone in Toronto. All of the work was done by a customer to find contractors to install the grid and fire suppression and so on. So I don't know what will be the choice for us, but we are tuned for very fast growth through direct.
And what is the business model that you think, because you might have done an idea maze of, okay, how should we charge? What should we charge for this? How should we think of a business model for ARAS? Is it ASAR? Is it
It's storage and retrieval system, ASRS?
Oh, okay, perfect.
Old school abbreviation, but it's stuck so deeply in this industry that unfortunately, there are other terms, right, flying around, but people generally say robotics, right? They try to generalize, but robotics is so broad that sometimes they need to speak more narrowly.
No, that makes sense. Standardization sometimes is good. So how did you guys land on a business model? I don't know if it's going to change in the future. I don't know if you know it too, but what was the kind of the idea maze that got you where you are right now?
So the kind of cornerstone of any good new product should be, if you especially are pressing on kind of better price, more affordability, it's better cost, right? So the cost structure should be different. You should have some inherent benefits in the cost structure. That's first and the most important, right? That we have a room to play. And how to deliver the advantage of a good cost structure to a customer, we thought initially that it should be completely as a service model, right? So more or less James Watt, right, theory. That's the best way to de-risk your customer. You're saying, look, you're paying me, you're essentially renting the robotics. You're renting the capacity. And you're paying per day, per throughput, whatever. But then, of course, when you're successful with a completely as a service model, you have to be very careful with the working capital. What are your debt facilities? How do you finance all of that? It's probably the worst way is to finance it through equity money. That will just it sounds like the worst way from a perspective that the money are bad or anything. It just fundraising consumes so much of your time that you are not spending this time on other very important problems, right? So if like CEO and leadership team is spending 90% of their time just fundraising just because you're successful and you have to finance the model, like, okay, don't go there, it's bad. So at the moment, we just said to ourselves, look, we are going to follow the customer. Whatever customer needs from a financing perspective, we will do. So we right now offer, you can rent the system up to certain size, up to 5,000 bins. You can rent both storage and throughput. If you are above 5,000 bins, you have to buy storage at least, but 5,000 is completely enough for you to try it, test it, see the benefits, integrate it into your process. If you want to buy the storage, no problem. You can buy storage at any moment, right? Even from the very beginning. And if you want to buy the robots, it has to be a big system, right? So you can buy, you can rent. We can even give you if you're a customer, we give you the blueprints of the grid, so you don't feel vendor lock in terms of you can build as much grid as you want. Grid is such a simplified structure and process that here we can give it to the customer as a guarantee that they don't have vendor lock-in. Of course, robot manufacturing is much more sophisticated, several, like let's say 2 orders of magnitude. So even if I say, hey, the robot is open source, that's zero value to people out because, okay, great, it's open source, nobody can compile the kernel, right? What's the value? But with Grid, that is easy and that's compilable. Other people can take it and manufacture. So that's the model. It's basically, we have to, in the beginning, we decided that we will be not fixed on any one type, but we give the rental option. That's the most important to de-risk the customers, especially those customers who work with a startup, right? Because there's always this question, okay, I'm working with a startup, what if? What if you acquire it? What if you go bust? What if? And if you don't have right answers for the customers in terms of how you really de-risking the situation, then you will have some number of nodes just because you are small. Nobody gets fired for buying IBM, right? And you are not IBM at the moment.
Yeah, and that's a consideration that you need to have walking into the customer's headquarters, because you need to know the expected value there is that they will outlast, or the startup at that specific risk stage. Then you need to de-risk the product even when the company is not de-risked. That's actually a very good consideration that a lot of deep tech companies have to do in a lot of different industries. For example, a lot of the guests that we've had are construction robotics, and that for them is, yet again, if you're finally getting into the enterprise customer agreement with a construction company, you are becoming a piece of infrastructure that by definition never changes. That they have taken, the last piece of infrastructure took 100 years to change. So they want somehow to know that you will be performing the work, or that they will be performing the work without you with that equipment.
Yeah. Things like code and escrow are very normal, right, in this industry, and I've seen how that works. From a legal perspective, from a technology perspective, I'm not sure kind of this is really useful, but at least it's kind of giving some protection to customer. I think the simpler the tech and the more people understand it around not only vendor, but more other companies, the more partnership company is having, the more de-risk customers are. But of course, you cannot de-risk 100% completely.
And the question I would have is, given what you're seeing happening within the warehouse, um, in retrieval of inventory and dealing with inventory, here's the big part that you guys are deciding to tackle. What else within the warehouse do you think will get a big reshuffled, or at least a big improvement and advancement in the next few years? Where else do you see opportunity? Everything? Tell me about it.
Absolutely everything. Because warehouse is this interesting machine that is, there are a lot of them, first of all, right? They're semi-structured, they're commercially owned. In a sense, it's not an open street. So when you're, programming Waymo, you have to program it to be safe for unknown gazillion number of situations. In the warehouse, you have much more control, right? So it's much more structured. You can say, people don't go there. Here's a sign. Here's a line. Just don't step over it. Here's a cage, and so on. You are very flexible. There is much more control. So every process in the warehouse, from the yard to the kind of loading back into the last mile vehicle, can be automated. The question is in the value relative to the cost of automation, right? So the warehousing world is trying to cherry pick the lowest hanging fruits at the moment. And of course, some processes are more prone to this automation. And I think the fulfillment itself, where you do picking, is more prone to automation based on this value criteria, just because when you look at the cost of running a warehouse, right? Especially in the warehouses that do e-commerce fulfillment, the human pickers, it's a gigantic piece of your cost, and you want to make those people much, much more productive. It's not only, it's not like, very often people think, oh, replacing humans. And there is a certain element of that too, but just paying a lip service, very often people say, oh, we're improving productivity. Absolutely, we're improving productivity. But what's more important, that you can do more business out of the same building. Moving between buildings is a very dramatic process for any business, right? Like adding a new building, okay, but moving between buildings. So it's always good to make more business out of the same building. You were pushing out 10,000 orders a day, and if you can push 20,000 orders a day from the same building, that is terrific. But that is possible only if you improve density and you improve productivity of throughput, basically how many orders one person can fulfill. So storage and retrieval, which is basically goods to person system, are the prime suspect for being in the forefront of automation. But everything else can be automated too. Unloading trailers, loading, unloading, moving inside the warehouse, packing, breaking a case. And of course, I'm not even mentioning each picking, because again, what we are talking about, like you can think about this in 3 levels, right? You have by the levels of containerization, you have level of shipping container or like truckload. Inside you have pallets. After that, you have a level of some kind of boxes or storage medium as plastic bins. And then you have individual eaches. Every time you go from one level to another, you do times 20, right? So just for the sake of simplicity. So container would have, let's say 20 pallets. On every pallet, you would have at least 20 boxes, 20 bins. Inside every bin, you would have at least 20 eaches, right? So the last level, the operations with eaches, we are on the level, basically one before last, right? We are managing only plastic bins, but humans still do plastic operations with items inside plastic bins, right? They take something out, or they put something in. And of course, there is a huge area of picking arms, where people try to teach arms to do those operations reliably. There are multiple already kind of successful use cases. You've seen one of the latest reverse acquisitions of Amazon of covariant. And so that area has even more attention just because of like 20 times more operations in it. And of course, it will be also automated, but it's harder to automate.
And I think, first of all, I love the mental model that you just gave us. I don't know if it's standard in the industry, but I'd never heard of it. Because if you think about it, like the automation complexity also goes with the inverse of the size of the container. Because query, like the query operations where basically Crane is picking up a container from one point to the other.
That was automated
world.
first, right? That was automated.
Yes, that's easy.
Yeah. And in Europe, Rotterdam is, of course, the pinnacle of that automation, probably.
Yeah. And I've seen that, by the way, now in a different, in the last episode, the two before this episode that will come out, we have talked to someone that's looking to automate port operations and kind of like rail and road operations once the container gets off the ship. And then second, you have even forklifts, and I've seen automated forklifts driving around, and you can literally take up a pallet and go there, and then kind of like it's very brute to unpack a pallet and separate the boxes. What's fine working, it's dealing with the box and inside the boxes. You don't want to break that product. You want to make sure that the kitting is done right. And so even kitting, right, like putting stuff in the right place within the box, it's a very complex problem. And it's not obvious.
Yeah, packing, the last part of the packing is probably the most delicate, and because it requires a huge variety of operations that humans actually do when they pack, right? You're putting things in some order. Then you're putting some liners, or then you're closing the box. So when you look at the human hands, when they're doing all of that, they exert incredible dexterity and skill. And I think this will be the last part to be automated. So each picking automates one step before that. It's basically getting all eaches into the same container so that the packer is not spending any more time on picking. It's only doing the actual packing, right?
It's incredible. That view gives us like a loading bar of automation of human operations within transport of goods. It's like the loading bar now, it's actually not that far, but we have line of sight for what the rest looks like. I think the next step is exactly what.
And guess what? Once you automate more and more stages, it becomes more and more looking like a cage with a society of robots inside.
Yeah.
And that absolutely its own uncharted territory problem, how to make all of that work together, because you will not have robots from one vendor doing this, right? It's hard enough to make robots cooperate well when these are robots from one vendor. Imagine that now you have several robots from several vendors, and they have to basically agree to not be stuck, to not slow down, and to do it fast. That's an integration challenge of its own. The modern integrators are not equipped to solve this challenge even closely. That requires sort of new startups, new companies to think about it. And there is a challenge of working with other vendors, right? Because when several nerds are getting together, they have opinions about how things could be integrated. Always.
Yeah, and that's why interoperability also makes sense. But we have seen like big open source movements like ROS getting somewhere, but not getting all the way there.
ROS is how do you, it's interoperability within the robot, right? Within the body
not
of the
outside
robot.
of it.
But it has very little to do with like between the robots. Between the robots, there are some attempts, right? But we're still in the very early days. Typically, you have some form of human in between. And I guess a good example is a combination of picking arm and a CRS system. That's one successful example that I can give you. This is where integration happened from different vendors with high performance already in certain cases. And so I think it was already a success. It just had to be replicated. And of course, as usual, the cost should be brought down because the cost of picking arms today is just
Nonetheless, you've seen like United, you are
Universal Robotics.
Universal Robotics, kind of like make something that's as close as possible to the customer. Yet when you go on industrial sites, you realize that the integration cost, it's
it's not just the arm,
game.
right? It's the end effector. It's all of the, I don't know, pressure that you need, or changing the tool and the integration. That's what's problematic. It's not, whenever you see technicians sitting near device on customer side for many months, you like immediately can make a conclusion, okay, it's not mature yet enough for successful business because it just cannot make money, period. When you see, like, sometimes I see operators who are looking at examples of those automation pieces, right? Oh my God, they roll their eyes and they say, like, I could have done this already twice faster, 5 times faster with the people I have. So from one side, it's painful to see, but from the other side, you understand that there is no other way. You're bringing the new device category to the market. It will be painful. You will be ashamed many times, but this is the way to go if you want to get it to the reliability level and to the mass market, right? Because the holy grail is when it is reliable and cheap enough so you could get it to, like, I'll tell you what, the number of, let's say you have, I don't know, 25,000 warehouses in the US, in North America, let's say, US plus Canada. From this 25,000, maybe only 500 warehouses are above 500,000 square feet, right? So you have absolute majority of warehouses, 400,000 or less, more than 20,000, according to my estimates. And you've heard many times the number, like how much warehouses automated. Sometimes people say 10%, 20%, 30%. The question, like, what kind of automation? Because, like, you installed one stupid conveyor, like, are you automated already or not? And I think with the number of warehouses with automated storage and retrieval system is less than 5%. And so it's a wide open space and it just waits for the proper maturity of the product.
In an environment where the net new labor that would achieve the outcome is decreasing, it's negative.
Yes.
So
you need to increase productivity and by some significant margin. It's not like nobody's interested if you're just making things 20%.
Yeah, this is something that also in the very first episode of this podcast, another founder of a robotics company said, it's like, nobody cares anymore about getting 20% margin.
You see it even in demos. I have this sort of mnemonic rule, you can say, that if the robot is moving or is doing something that people subconsciously decide they cannot do, then it's valuable. Because if the robot is moving with the speed you can move, even if it's a good economics, the demo is not impressive. You have to be doing something in a demo that subconsciously people look at it and they think, wow, I cannot do that. So in our case, for example, individual robots are not moving that fast. It's the collective, the squad, the swarm of robots, what creates productivity. But the robot can drive 6 meters above you. And I'm always demanding, like, at least one wall of the grid to be transparent so that you can produce a demo where a person can stand near the grid and 6 meters above you, you see the robot driving on a ceiling of that level with the bin. And then subconsciously you understand, like, okay, there is even if I have humanoid robot that is completely can do everything as I can do in humanoid, it cannot do that, right? So it's beyond human capabilities to be out there or to move that fast. That's what your demo has to show. All the demos where things just moving a little bit with sort of semi-human performance, they're not impressive much, right? Then the only way how you can create impressive demo, there is one trick. You have to have a lot of robots. You have to basically bring people in the room and show them 50 robots doing this choreography of some movement. Then it can be impressive.
Yeah, that's completely true. And I think this is what it's giving me pause. And I'll say something controversial here, but it's giving me pause when I look at the form factor of humanoid robots in a lot of the funding that comes with them. Is like, yes, the word is made by humans for humans, and you have plenty of applications where basically physical fingers that move with really good actuators are perfect to do certain things. But for the vast majority of movement from A to B of things, and stuff that we have to move, stuff we have to manipulate, I feel like the non-humanoid form factor might actually make more sense. And I don't know what you think about that. Where do you see humanoids in the future going?
Humanoids are the future. They will be here. It's the only question in timelines, right? And again, for it to be massively applied, you have to have them safe at the right price point. And I don't know how far are we from this, right? Humanoids are the future. I don't have any doubt about this, but they have to be at the right price point and extremely safe and extremely reliable, right? And I don't know how long it would take to get there. So this trajectory, that's what is the most interesting. It's not the end point. The end point, we know there will be some very universal humanoid robot that is capable of doing everything, almost everything that humans can do. But the trajectory there, that's what is the most interesting. What will be the earlier version, the beta version of that is already valuable in some use case, right? And at the right price point for that use case. Of course, factories and warehouses, they represent a nice opportunity because of what being said, because they are structured environments. There are certain tasks where the robot can be helpful and valuable, and it's only one task, 2 tasks, 10 tasks. So they give you a field where this trajectory may go from one point to another, like starting from this and then getting more complicated. So I think the next, I would say, 3-4 years, most of the value will be created in those structured environments. And in the house, in my home, I don't think the humanoids will be. It's a mass market, I understand, but you need so much to invest and so much to research and improve in order for it to be really valuable for a normal family that I don't know how long it.
There's a lot of money to be made in the road to that with different form factors, different architecture. That's pretty much the idea.
Well, look, like I don't know, somebody can do your laundry and put dishes in the evening into a dishwasher. Are you going to pay $10,000 for that something? Like, I will think
Probably
twice. If you remove the toy component, right, the toy, the excitement, oh my God, humanoid robot, if you remove all that and you leave only utility, like, are you, for your laundry and some chores, how many dollars are you going to pay? Right?
Yeah,
it's like buying another car, right?
Yeah, and that would actually put even a discount on that, because I think people in the long term will actually like having a humanoid that does things for you, but at the same price point, can get I don't know, the equivalent of a butler or someone that does my home services, etc. I think the human would prefer the human, So you really have to be below that price point to get that done.
Absolutely. So, like for me, much more clear in the short-term perspective, much more clear use cases are construction, warehouses, factories. These are the boring, repetitive, sometimes dangerous jobs that people do not like to do. And they're in a more structured environment, and you can make them safe. You can create this mega cages where robots cooperate. That's a path where I think in the short-term perspective, we'll extract the most value from robotics and automation, and including humanoid robots. And like if you take all of that and you bring it to space, even better, right? Let it all happen on some orbit, and like let's not pollute the Earth with all of those manufacturing processes. And you leave Earth then to humans and to kind of normal human family life activity. That'll be great. But of course, yeah, I'm seeing only one segment of this movement.
Yegor, I love what you're building. I love what you built. I love your mental models, and I think your podcast will probably be the longest that we've recorded so far. And I think it's for sure to the
Feel
merit
free
of
to
the
cut
fact that
out anything you don't like.
I honestly don't think I will cut anything out of this. I have one last question that I want to close up with. Something that I like to ask the founders and the operators that come on this podcast, which is, what would be your advice for someone building something hard like what you're building, or something that has to do with, physical movement, physical complexity, stuff that's just extremely easy to bankrupt with, and is extremely easy to give up on. What would be your advice for a young founder?
Well, I think one of the hardest parts in all of this hardware journey is timelines, right? It takes a lot of time. Some people think that timelines is even incompatible with a venture treadmill. But I think this is a wrong notion, the wrong way to look at it. So I would say there is no need to be afraid to be a little bit longer in your development, but then come with a little bit more mature tech and product. Like, you will be ashamed in any case with your first couple of installations. That's almost guaranteed. But it should not kill the company, so to say, right? And in the robotics, it's just a graveyard of companies that were killed by robots that are either too expensive or not generating the performance promised, or too unreliable. So you can always hide timelines, right? Or if you believe how VCs will be looking at me if I was developing something for 5 years, they will be looking in a bad way. Even if you believe that, that's not true. But even if you believe that, you can always kind of play with timelines, right? I think it's better to stay a little bit longer than you think you might in the active development phase. It's not like you have to move slowly. No, you have to move very actively in that phase. But when you come out to raise money or to your first set of customers, the thing you show has to have enough of this value, a differentiation, right? And enough of reliability. What is enough? Of course, I cannot quantify. Everybody will decide, but you will see that there are so many challenges that it's better to solve them. Once you will be with your couple of first customers, or with first institutional investor, then there will be a real closer look at your velocity. And velocity is, I think, number one problem in this industry. It just takes a lot of time to create something valuable.
It makes perfect sense. And I think it's going to permeate the life of these founders, the feeling that they're never fast enough. But I think it's only a matter of finding the means to, achieve those milestones that will unlock the next one. It's always been about that, and I think it'll continue to be that. I love that. I love this conversation, Yegor. Thank you so much for taking the time. I'll leave you back to building the robots that fly on ceilings, that just go super fast with the glass ceiling, leaving the operator.
Just drive, no flying.
No
just
flying.
driving.
Yeah. No, please, not flying.
Yeah.
Thank you for this, and I want to see you again for the part 2 at some point. So let's stay in touch.
Thank you, Gabriel. It's a great pleasure.